Hello everyone, it's a great day for math again. This is Mr. Tan here, and today we're talking about the chapter on sets and in particular about Venn diagrams and what is the complement of a set. So this is not the start of the chapter, so you should already be familiar with the idea of sets being groups, and the diagrams that we've been seeing basically are referred to in mathematics as Venn diagrams. So these Venn diagrams just give us a very pictorial view of how the groups are done. Now the new term of this idea of a complement of a set just refers to the elements that are not in the set of question. So first of all, if I were to look at a set A inside a Venn diagram where the universal set represents the big rectangle first. So this is the largest group in that question. Set A is inside it and we shade it as such, right? Now, within the same universal set, the complement of A now refers to everything that is not inside A but rather outside. So the complement in this case would be everything outside the circle, or rather the group of A. Whether I represent it as a shading like I'm doing right now, or I represent it by placing the elements on the right here, they refer to everything that's outside of A. So that is the complement of the set A. So if we dive a little deeper into some examples, notice that most questions, or in fact all questions, will start with what the universal set is. So this biggest group that we talk about in this question is all the alphabets in the English language. So by right, if I can draw it by this universal set, a Venn diagram, then basically A, B, C, D, by right should fit all the way till Z, fit inside this big rectangle. But now I have to consider things that they want us to further fit, smaller subgroups. For example, in part A is the set of A, B, C, D, E, and B is the set of A, E, I, O, U, right? So for part A, this is how I'll do it. I will first draw the universal set, the bigger set, right? Hope you remember how to draw the universal set with that symbol. And now I'll fit A and B inside. But before we even do that, note that between A and B, there are common things, right? A here, B, nope, not B, sorry. Any other thing? No, nothing else in common. So generally, these two groups actually share something in common, so they will have an overlap of a small region here, where I will place the element A inside. Please note that in a Venn diagram, I will not be putting the commas because they would represent elements as well. So instead, I will just list it as, for example, B, C, D, E, without the commas as you would write it in a set, as above. So this is set A, and this is set B. So I'll place the rest of the letters, E, I, O, U. Notice that I purposely space the letters out so I can easily differentiate the letters and the elements inside each group. Let us not forget the rest of the letters of the alphabet, starting from F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. Oh wait, I made a mistake. I'm sure some of you have spotted that actually E is something in common. So my bad. E actually belongs here together with A. That's the overlap, right? So that's part A. Part B, we have two different sets, but again, the universal set is the all alphabets. So we have A and B. Set A, set B. B being the words consonants in the word winners. Those are non-vowels, so we have W, N, R, and S. So once again, we're going to find things in common. S is in common. Anything else? Yes, W and the letter N. So 3 things, and I'll just directly write them here first. W, N, and S. The rest of A consists of P and M. The rest of B consists of R. Now I just have to fill up the rest of the universal set that are outside of A and B. So it's literally counting my alphabets again. A, B, C, D, E, F, G, H, I, J, K, L, M, N is there, O, P is there, Q, R, S, T, U, V, W is there, X, Y, and Z. Right, so that's part B. Drawing a Venn diagram and fitting all the elements in the different groups. Next, we have the universal set of epsilon, all these activities, CCAs, and A, a specific set inside our universal set, and we are expected to know what is A complement. So basically, recap, A complement means outside, a set that's outside, containing all the elements that are outside of A, yet still within the universal set. Okay, so that will be A complement being things like football, volleyball, tennis, and let's check. Yep, that's about it. So that's identifying the A complement. Next, question 3. Universal set, letters in the word mathematicians and letters in the word mathematics. So if I were to write it out completely, not in set builder, it's M, A, T, H, E, I, C, N, and S. And for set P, M, A, T, H, E, I, C, and S. Oh, right. Actually, we've done part 1, right? So we've listed the elements of the universal set. I've listed the elements of P. So P prime basically is things that are outside of P, yet still within the universal set. So if I compare these two sets here, things that are outside, there's not many. They share many things in common. Notice that N doesn't appear in P. Any other thing? No, only N. So the set of P complement, or P prime we call it, some of us, is just a set with a element of N inside. Last question here. Universal set, positive integers, whole numbers, and we have an inequality. We will simplify it. So simplifying this, we get 4x less than or equals to 44, and x less than or equals to 11. So if I were to list this set, it contains things such as 1, 2, 3, all the way till 11. That's the universal set. And now if I go digging deeper, a smaller set inside the universal set, A would be made up of positive odd numbers, so 1, 3, 5, 7, 9, 11, and we will stop there because it cannot be bigger than the universal set. So now if I answer A prime is simply things outside of A, yet still within the universal set, such as 2, 4, 6, 8, 10, and that's about it. If I were to convert this to set builder notation, A prime could also be written as X, elements of X, where X are positive, even integers with a boundary of less than 10. And there you go.